This is Diana Karwan. No further ado with introductions because of our issues here. Diana, you're on.
Thanks, Eli. Yeah, so I'm Diana. I'm a faculty member here in the Department of Forest Resources, and I love water in forests. And so what I'm going to give a brief overview of today is some ways to think about hydrologic effects on amount of water and water quality of forest management. So a brief roadmap of the things that we're going to touch on here in, say, the next 40 minutes, and I have a break in the middle for questions. In general, water and forest management, what can happen with a water balance? Sediment concerns involving water quality are we still having issues?
Keep going.
Keep going? Okay. So sediment concerns, sediment being the #1 water quality concern that's often associated with forest management operations and a lot of landscape changes. Best management practices, or BMPs, are one of the key tools that we have in order to address some of these sediment concerns that come in conjunction with forest management. And then we're going to take a break for a few minutes and hopefully have slides and voice by then. And give me the opportunity to answer any questions. You guys will see pictures of nice streams on non-rainy days. And then after the break, we're going to talk about some things that can be hot research areas, but are also really important when we're thinking about looking at water quality data in order to evaluate whether or not our best management practices are working and whether or not our any landscape activities may be having an effect on our waterways and water quality. So just some things to keep in mind and maybe some limitations of those effectiveness checks. And I have a case study that's not from Minnesota, unfortunately, it's from Idaho, but a watershed I have tons and tons of data on over decades to give an example of how these considerations come into play when we're thinking about harvesting and water quality measured by sediment. Right, how do I advance slides? Hang on, wait, let me try one more thing.
Let's try clicking somewhere on that.
Are my slides advancing for you guys? Okay.
There's an animation here. Is that...
Yeah, no, but this isn't changing. Okay. I'll go with it. So you've gotten to see my talk in 10 seconds. Okay, so water balance in a forested watershed. Oh, they can't see it. Go for it, one more. Yeah. Okay. Okay, so water balance. No, I can't see it. So if we're talking about water, say rain or snow, coming into a watershed that's got trees in it. And so we can think about what happens with that water. Once it comes in as precip, or once the snow melts, there are different kind of pathways or flows that it could take. What some people don't always appreciate is how much of it the plants process and send back to the atmosphere as water vapor through evaporation and transpiration. Because those are big, long words, we abbreviate them ET in hydrology. So from a typical forested watershed, anywhere, say, across the continental United States, the whole northern swath of it, from the Pacific Northwest to New England, including Minnesota in the middle, usually somewhere between 40 and 70% of the water that comes in as precip annually is returned to the atmosphere as vapor. About another quarter of it will infiltrate and move through the underground, through the soil, and perhaps through shallow groundwater, and come back to a stream channel. And this will leak out over the course of the year, and it's called base flow. This is the water that's in the streams when it's not raining at the time, or when it hasn't just rained. And on average, about 10% of all water that comes in as precip is what leaves the watershed quickly during a storm or during storm flow. So even though that's what we see, and it's what we see today in places where maybe it's raining a bit harder than it is here in the Twin Cities, on an annual basis, this is really not the majority of that water budget. So to bring this to Minnesota, these water balances have been constructed in watersheds in the Marcel Experimental Forest in Itasca County over the course of decades. So to take those averages across most of the northern US and place them in Minnesota, northern Minnesota, about 2/3 of the water, or 66%, goes back to the atmosphere as ET. Another just over 10% here actually leaks out the bottom of the watershed and goes into groundwater aquifers. And just over 20%, 22%, in the absence of harvest, is what they see coming out of the stream channels. However, when they did substantial upland harvests, what they were finding on average from their several studies is that this amount going out in the stream increased by 30 to 80%. So harvesting, in the absence of looking at anything in the water yet, is increasing the amount of water coming out of the watershed in the stream channel. Because we're concerned with water quality and not just water quantity, particularly in managed forests, it's suspended sediment or the turbidness of the water that we're concerned about. So sediment typically is considered to be the most significant water pollutant associated with forest management and forest operations. And this is actually another turbid stream flow this is a rainy picture, and this is a managed forest in the Berkshires. So sediment, so what? What is it? Where does it come from? These are particles that are transported in the water column. They can be from anywhere, so they're mixed in composition and they're mixed in source. They can come from uplands, they can come from in the channel. They could be soil, they could be road material. And we'll talk a little bit more about them over the next few slides. They're studied across several disciplines, so anyone that studies water, whether you're a biologist, ecologist, hydrologist, you tend to be interested in this solid material that's moving down with the current. It's kind of a problem. It's a huge management conundrum because on one hand, we need this material moving through our watersheds to replenish floodplains and to carry nutrients such as phosphorus downstream, but we can have too much of a good thing. For example, if you have too high of a sediment load for your particular stream, it can really disrupt the habitat and the biological integrity of your waterway. And in addition to just being the solid material that I've blown up for you here microscopically to show you what some of these pieces really look like, they can carry with them other contaminants and constituents of concern. And it's these last 2 points that we're going to take a little further on the next slides. So carrying with them other things, other materials of concern. The EPA's top causes of surface water impairment, so water bodies across the US that according to the EPA aren't meeting their targeted quality goals. You can see that sediment and siltation, or measured as turbidity, so how cloudy the water is, are both within the top 10 nationally, and I think they're even higher on the Minnesota-specific list. However, if we look at what's above sediment and siltation on these lists, we have things like pathogens, mercury, other metals, and nutrients, and possible organic enrichment. Many of these, including pathogens, mercuries, metals, and phosphorus as one of the nutrients, travel on these sediment particles. So when we're talking about sediment as a metric of water quality concern, we're often going to see positive associations with other water quality concerns as well. So we can think of everything, biohazards, radionuclides, other toxic waste, literally hitching rides on these little sediment particles. So how do we evaluate sediment coming from water quality concerns? So you're managing a parcel of land and you're given a water quality report, say. What might be measured in order to indicate if there's some sort of a sediment concern? So often you'll see something called total suspended solids or suspended sediment. And literally this comes from people like me going out at various times, some of them pleasant, some of them more wet and cold and damp and rainy, and taking water samples from the stream, processing them, and coming up with an amount of solid material on a filter. So we can tell the mass of solids per volume of water, and that's going to give us a sediment concentration. A second way that this is evaluated, and we see this in a lot of forest BMP studies, is to think a little bit more down the line of the stream ecosystem, saying what's happening with the stream habitat and various ecological communities. Because we know things like stream bugs or benthic and aquatic macroinvertebrates will respond to changes in sediment concentration and sediment loads. So what we can do, like what Justin's doing in this picture on a much sunnier day, notice than when I was in the stream collecting water samples, is collecting the invertebrates that are within the stream bed. So samples are taken, say, of invertebrates and or fish, and different metrics of those communities are measured in terms of their diversity, the number of taxa, the number of certain types of genuses that might indicate a certain condition. For example, if it's a sensitive species or not, their presence. And so I bring this up because this is a common metric that a lot of times you will see what happens with various landscape practices. You'll say, did anything happen to this aquatic community? And from that, some of the water quality, especially the sediment, is kind of inferred. So what do we do? If we're proposing a management operation on the land, we want to have some tools in order to protect water quality. Those tools come to us in the form of BMPs, right? Sorry. I have a different set of slides on the screen than you guys are seeing here, and I don't know what everyone on the internet
We're seeing what's up there.
You're seeing what's up there? Okay, great. So if it's just me that's off, I'll adjust. So the tools that we have in terms of technology to manage the sediment coming off of our harvest areas is in the form of BMPs. And so I'm sure many of you are familiar with some of these, so we're just going to highlight a few of them here. And really call to attention, the goal of these best management practices is often to keep the soil and sediment on the landscape and out of the waterways, right? So this is really kind of an edge of field or an edge of landscape tool or technique. One that comes to my mind right away is riparian buffers. I think many of us are familiar with this on streets of certain sizes. So what we can see here on the left is an example of a very thin buffer that's maybe along a stream that's not yet fish-bearing, where a thin row of trees is left, either from having all leaf trees or having it be some sort of equipment exclusion zone, for example, where they can't drive into that area, but they could reach in and take trees out. And on the right, you're getting an aerial view of what this might look like. So a hydrologist will often look at landscapes like this and pick out the stream channels right away, because we know that often the riparian areas are what's left intact. And so your streams will probably map in right along here. And in fact, a lot of the research that has been done highlighting the effectiveness of BMPs has been done looking at some of those aquatic ecological communities and how they respond to a buffer being left intact or a buffer with some harvest and some retention, for example. And this is a lot of what is behind the current forest management guidelines in Minnesota goes to studies such as this. They get published in the academic journals such as Forest Ecology and Management. So this was a big study that was done over the course of a decade or so, starting around 2000, and had different sites in the early 2000s and then later in that decade, looking at the influence of partial harvesting within riparian buffers and what happens to the invertebrate and the fish communities. So what this group did, excuse me a second, was to have kind of this study design where they had harvested areas in either an unharvested RMZ or a harvested RMZ or a partially harvested RMZ. And then they went in the stream before and after those harvests took place and evaluated the ecological communities. So they looked at aquatic macroinvertebrates and fish within 30-meter RMZs Most of them had an upland harvest associated with them. I don't think the controls did. And then some of them had no RMZ harvest, and some had partial harvest within the RMZ. And so the study, they made sure they went out 1 year before the harvesting and then 3 years following. And they found that they didn't see any overall effects based on the RMZ treatment, based on the fish communities. The aquatic invertebrates, they did find some variation from year to year, but there wasn't anything that was systematically associated with the harvest. So they think maybe that this is just a fluctuation due to a different process or a different driver. And it's, let's see, they're studied elsewhere too. And this is a paper, if anyone is interested in going to the literature, Eli, I can share this with you guys. It's a 2016 published review. So it's a great way to read one paper and find out what about 100 people did in these various studies. And what I like about this one is they synthesized it by region. So what this allows us to do is look into this grouping of kind of the upper Midwest and the Northeast and see what were some of these key studies that have been done over the past decade or so. And many of these go back to different riparian buffers, but some are different riparian buffer studies. But some in particular look at other BMPs, such as crossings and road designs.
By the way, Diana, I'm going to interrupt for just a moment.
Yeah.
A couple of things. One is, yes, we will definitely share that link with folks after the fact. And I was just reminded that I didn't give instructions on how to submit questions. Folks, you can do that using the chat pod on your screen. And please make sure when you send it, you submit it to the host or to Julie Hendrickson. Those may both be options for you, and you can submit questions anytime. We will pass those questions along to Diana during a pause. We don't have any questions now, so go on. Thank you, Diana.
Because they didn't know how to ask them. Okay, so yeah, we're coming up to a pause in just a couple more slides here so people know kind of where we are. So crossings and road design is another one that's been studied for a very site-level, site-specific practice that can serve to keeping the sediment and the soil on the landscape itself, as opposed to making it into the waterway. And so, for example, where it all did, several studies related to this, mostly in the Piedmont region in Virginia. So their design is shown here in the figure, where I think the stream flow is the blue line going from left to right. And they would have some sort of a stream crossing, and there's an approach going into that stream crossing. And what this group did was to look at different closure treatments, such as slash, mulch, and silt fencing, and how those did keeping sediment out of the stream. So they could take total suspended solids measurements that bottle in the water, giving you a concentration of solid that I talked about earlier, both upstream and downstream of the crossing, and compare to see if they're seeing an effect downstream. And how might that effect change with these different closure treatments. So they found, first and foremost, minimize your stream crossings to minimize your effect to hydrology. You guys probably don't need me to tell you that. Secondly, they found that these closure treatments did work. They were found to be effective. And one of the things that they noticed a sensitivity to was the type and the amount, and say the type of rainfall that's coming on those fresh crossings and fresh approaches. So having a closure treatment in place is great, and it may or may not be activated in terms of needed hydrologically based on if it rains or not, or how much it rains, which is not something any of us deem to have much control over on a site-specific level right now, at least as far as I know. And this is the study, Eli, I said I would share with you guys because it's sort of reading one article and giving a lot of information and options for going further. And I just wanted to point out in Minnesota, we very recently, within the past few years, had these forest management guidelines and the quick reference guide in the pocket size come out. And there were studies, such as the ones I've highlighted, that really went into developing these BMPs that you see on in the flip chart. So what are some of these common BMPs? Having techniques to divert water and kind of control that runoff going directly to streams, right? So like the crossing approach we just discussed. That also feeds into how you would design a stream and wetland crossing. Things like RMZs and filter strips. So really a lot of these, I keep hammering this home, the BMPs are to keep the soil and sediment on the landscape, to keep the land on the land and the land out of the water. And the studies have found that the bottom line is these do what they're designed to do, to kind of cut off a pathway when they're implemented and when they're used. So what we've discussed so far is that removing vegetation can shift that water balance in a catchment. So that's a quantity of water. We then went into talking about the quality of the water that's going out that we're measuring in the stream and saying that sediment's the main water quality concern. We can measure sediment concentration directly, or we can measure it in terms of its ecological implications and look at the invertebrate communities or the fish communities. But what the BMPs are mainly designed to do is to keep that sediment from entering the waterway. The BMPs aren't as much dealing with the whole water balance cycling or the amount of water going one place or another. They're trying to keep the sediment plumes from making it into a waterway. And we'll talk about those in a little bit as being a direct effect of a BMP. We're really trying to cut off a sediment flow pathway. But I will take a break there, and we can all kind of metaphorically look at the stream and think of what questions we have right now.
Okay, thank you, Diana. A moment ago, I asked folks to submit questions to the host, and if you have already done that, then they will get to me, so that's okay. But I'm going to change that instruction. Please send your questions now to all panelists. If you click that chat pod, you will see an opportunity to select who you want to send those questions to. Please select all panelists. And we'll wait just a minute here and see if any questions come in. And otherwise, we'll have Diana continue. We have cut Diana's time a little bit short with the way that our event started, so we won't wait too long. Again, you can submit questions at any time, and we will get those to Diana. Okay, looks like we have one question. Okay. Oh, we have several questions. Okay, question, does that mean buffers aren't important, or was the study poorly designed or flawed in some way? I'm not sure exactly which study that's in reference to, Diana. Is that clear to you?
I would make an assumption that it's the Chizinski study that was done where we were directly looking at buffers as opposed to the ones where we were directly looking at crossings, because the crossing would necessitate transversing a buffer, right? I think with the Chizinski study, that was the first one I really highlighted and focused on, did show that buffers were effective, because we weren't seeing any effect within the stream ecological communities, so the bugs and the fish, based on if there was an unharvested buffer or a buffer that had a partial harvest in it, right? So we didn't, I believe, evaluate a treatment that was full clear cut all the way down to the stream. Right, so everything had some form of buffer. It either was not touched or it was a partial harvest within it. So my takeaway from that study is that even a partially harvested buffer is kind of keeps its ecological integrity in terms of the aquatic species that were evaluated.
Quick definition here. Closure treatments, does that mean after harvest when they're packing up, leaving the site, they do the treatment then?
I believe the study was looking at, yes, packing up, leaving the site, when they weren't going to use that crossing anymore. So I don't know if they were still in that harvest area, they were just done with that particular crossing.
Wow, this is great. We now have a bunch of questions. How long does it take for water balance to return to normal?
It totally depends on where you are. So for the studies that I highlighted, there were a couple of studies that Sandy Berry orchestrated up in the Marcel Experimental Forest. The harvests were done in the early 1980s. They were finding it was maybe about 15 years before that water balance, annual water yield kind of crossed back to what was within the range pre-harvest. But that's one example with one sort of community, one ecological type in the Marcel Experimental Forest. If you were to look at other forest types, even throughout the whole range that we have in Minnesota, that 15 years would be kind of a place to start. And if you think about what's happening with anything going on after forest, whether it's seeding back in and the trees growing on their own, or whether you're using some herbicide to suppress regrowth, it all depends on what's going on. But think about when the trees are big enough that they would be pumping water again, like the pre-harvest forest. So there could be changes with species, for example.
Okay, great. I'm going to ask Michelle, who submitted a similar question. Let me know if you want further clarification or if that answered your question. I'll be watching the chat pod. Another definition question. What do RMZ, SMZ, and MP in the BM? Oh, I can answer that. Riparian Management Zone, Streamside Management Zone, and MP in BMP stands for management practices. So BMP is best management practices. Okay, next question, Diana. Have there been any studies done to look at tree roots in the riparian area and how they help hold streamside banks together in Minnesota, especially in areas where there's recent land use or land cover transition?
Not that I'm particularly aware of, but I would love to have a much longer conversation with whoever answered that question. And I can bring it up again as we move into the next segment of the presentation. I don't know of any direct ones, but what the trees do for processing water both above and below ground is something that I know is being studied in a lot of areas. The area of the country that I know that dynamic is much more hotly studied in the academic circles right now is more in California and the Sierras and places like that. I don't know of anything specifically in Minnesota, Wisconsin, northern Michigan.
Okay, I'm going to pass along a question that I'm sure could be the topic of a day-long workshop. I think it comes from the Orr area. Dana, please let me know if I've got your area wrong. The question is, my area has some concerns about how much harvest can be done in a watershed without adverse effects to water quantity and quality. Any recommendations on harvest levels within a watershed? Again, I think this is kind of far northern Minnesota, around Orr.
Not immediately off the top of my head, because all of the studies that I've seen in Minnesota, I'll point back to this Marcel work with Sandy Berry, where they say, no more than a third of the watershed in young, or is it 2/3 of the watershed in young treatment, which is that kind of 15 years and younger. But that was done in Itasca County in a watershed that doesn't have a lot of slope to it and that has a lot of wetlands that sort of detain water and would detain any sediment. And so I would think that the kind of nature's plumbing or the glacier's plumbing gave us something very different on the North Shore.
Okay, we're going to do one more question now, and then we're going to move on. I will be reviewing, so if I've missed your question, we'll get to it in the next round. This one, I'm going to have to spell out some acronyms here. Can you speak to the RAPS, that's WRAPS, and 1W1P modeling efforts using HSPF, bucket single model, and single efficiencies or rates for sediment, nitrogen, phosphorus coming off forested land?
So I know what a lot of those projects are. Things going on with RAPS. God, it would be great. Can I have them hold that question until after my second set? Because there's a slide that'll be really helpful for a study that I have underway right now.
Great. We'll come back to that one. Thank you, folks. Keep the questions coming.
Okay. So just a brief cap where we are here along the road. We talked a lot about best management practices and sediment and water balance concerns. I now want to kind of bin these into two categories of direct and indirect effects when we're talking about forest management operations and water quality. And then I have an example that I think I can highlight some of my concerns that fall more in the indirect category through an example where I have several decades worth of data. So when we think about direct sediment effects, this is what comes to mind, I think, and what was behind a lot of the BMPs, the best management practices that were initially designed. We are worried about what happens with material on the landscape. If we're reducing vegetative cover through a harvest, we're exposing more of the ground or more of the soil. Also, our network that we drive on, the roads, the skid trails, any other sort of stream crossing, those are all exposed surfaces that we're mechanically compacting. This leads to more area that's available for erosion should water hit it in rainfall, and it can slide down. So there's kind of this direct connection. Exposed surface, water can hit it, it can erode. That's great. So we have BMPs that we've talked about, right? We've talked about these riparian management zones or streamside management zones where we're keeping something in place right between the land and the stream or the waterway. So that kind of acts like a natural break. Anything that's moving an overland flow could be stopped there before it enters the stream. There's also probably the source of not just a day-long, but a whole week-long workshop and entire people's graduate degrees is how to engineer your roads. There are a ton of practices that can be done in terms of the slope of your roads, the slope of your road cross-section related to your topography itself, ways to funnel water off the road before it hits the stream, etc. Again, kind of a direct break that path from the sediment eroding to make it into the stream, a direct effect. Indirect effects, as I'm defining them here, is when we're talking about what the question that I kind of punted down the road, because it really feeds into this here. When we're removing vegetation and therefore changing some of these water cycle processes. So maybe we're changing the amount of water in the stream, even if we're not letting any sediment get there. So recall when we looked at our water balance slide at the very beginning, I said stream flow was normally about 22% of the average annual precip in the Marcellus experimental forest. But it went up significantly immediately following harvest, and say in the first 12 to 15 years following harvest is what Sandy and his colleagues were finding. So that means we have more water in the stream. That means there's more force going downstream with that water flow, and we can perhaps change what's going on with our channel relative to erosion. And this is where I would love to talk to the person who wants to know about streamside trees and stabilizing the banks. So perhaps what we're doing is changing the whole set of forces that's going on in the channel. And I'm calling those effects where we can see some changes to sediment indirect, right? Because they're coming through changing a flow situation and they're changing what's going on in the channel itself. Now, of course, I have cartoons and arrows that show this because I don't know if the people online can see me like waving and dancing up here. So we're talking about putting more water into the stream channel by quick and slow flow pathways, raising the amount of water level in the stream, and we're changing the force. Most BMPs that I'm aware of, this is not what they're designed to do, right? They're designed to keep the soil on the landscape. This links into a much broader suite of processes that deal with geomorphology and happen over a longer time scale as well than maybe what we're used to thinking about in terms of water quality management. And so there are current studies that I've been a part of in geomorphology where if you want to move, say, 10 kilometers down the stream, water might go right down, but some of these suspended materials could take years to decades to even centuries to make it that far down. So there could be a disconnect in time in addition to that changing of forces that's going on in the channel. Right? I said I call them legacy sediments, and that has different meanings in different parts of the country especially. But if you have material that's built up either in your stream or you have a really thick stream bank from previous, erosion events, say with agriculture that's been happening for decades to centuries, say on the East Coast, you could be eroding that material that's kind of in your channel matrix already. And so that is, again, not something that all these kind of field side, very local to site BMPs are addressing. So how on earth do we know where and when this material that's muddying the waters is coming from? And the hard thing is, a lot of times, based on the ways we talked about previously measuring it, we don't. If we think about it like mixing colors, right? The yellow and blue makes green from when Ziploc bags first came out when I was a kid. So if we think about material coming from the landscape or hill slope sediment being yellow and material already hanging out in the channel as being blue, we can think of that suspended sediment, or what gets picked up in our bottle of water quality sample, as being green. Maybe that green looks really blue, maybe that green looks really yellow. It could be some combination of them. And so this hill slope sediment, or say something coming from a forest operations area, could be in this yellow category. And so we don't specifically have a diagnosis in a lot of the current water quality framework for saying, if we are seeing an increase in sediment, is it yellow or is it blue in this very simple binary case. As we get to larger watersheds that have a lot more complex mosaic of land cover, land use, and land management, we don't just have yellow and blue anymore making green. We have sort of like 31 flavors making a rainbow. And so it just kind of gets to be bigger. There are current sediment fingerprinting approaches where we look for unique chemical signals that would correspond, say, something in the mineralogy of the sediment, something in material that sorbs to the sediment, to allow us to start to take apart this rainbow. But that's not something that's commonly implemented in a management framework right now. The other piece that I alluded to is this how long it takes it to get down the channel, right? So a paired watershed study that I've been involved with for a long time is the Mica Creek Experimental Watershed in North Idaho. So this is a large watershed that's set up into a paired nested design. So watersheds 1, 2, and 3 are all pairs to each other, and they're each a few square kilometers in area. Watershed 4 would combine all those, and that had gotten treatments, and it's paired to watershed 5, which had not received treatments up until a few years ago. So for the data we're looking at, hadn't had any treatments. And then they're again paired further down. So if we think about it, initially there was almost 10 years of water quality monitoring before there were harvests that took place in the shaded areas in watershed 1 and watershed 2. But the water quality and the water amount, the water yield, was not just, measured up at 1, 2, and 3. It was measured further downstream at 4, again at 7, and then it's pairs 5 and 6. So we want to think about how long would it take us if we're going to the stream and filling a bottle with water for that material that's in that water to make it, say, from 1 to 4, from 4 to 7, etc. So there could be this time disconnect with when we're looking for the effect and when it shows up. So the basic paired watershed results, sorry, I'll back up just really quickly. So watershed 1 received commercial clear cuts over 50% of its total watershed area in 2001, and watershed 2 at that time received a thinning treatment that removed 50% of the basal area, also over 50% of the whole watershed area. So following harvest, what we saw in water yield at the upper level in watersheds 1, 2, and 3, with 3 remaining the control, so that's kind of our unharvested one that we're comparing these to, we did see total amount of water coming out in stream flow per year going up by 20% in the partial cut and 36% in the clear cut. When we go further downstream, that increase remained at 20%. So the increase in water yield did kind of propagate downstream. However, sediment yield was a really different story. We had a huge increase that more than doubled in the clear-cut watershed, but that was only the first year following harvest. Beyond that, it was not detectably different from the 10 years of pre-harvest data that we had. And we did not see a significant increase in the partial cut watershed, watershed 2. That increase did not propagate downstream to watershed 4. So I had a lot of questions about, well, what happens with this material as it moves down the channel? If we're going to study the effects of an operation, how far downstream can we go, for example? And I was fortunate enough to have a couple of seasons where I could get this tracer information, to collect tracer information in this watershed. So there were a few studies that were done with tracers. One of which, to get at that in-channel transport time, like how far does it move and how much will move downstream. So we want to know if there's like a temporal disconnect between anything going on the landscape and where we're sampling water quality. I actually added clay tracers to the stream, shown here in white. It makes for great pictures when you turn the stream's funny colors. And depending on how close you're doing this to where other people are, you may or may not get a lot of phone calls from locally concerned citizens. In North Idaho, there was no one around. So I added just some white colored clay to the stream and then sampled it going way far down. And the punchline here is that we found about more than half of what I added was lost over less than half a kilometer. So the suspended sediment isn't necessarily moving right down with the water. So it can remain in the reach and be picked up at a later time. Using some of that chemical fingerprinting approach I mentioned earlier with the color mixing and the color coding, I used a fallout radionuclide, so something that's produced in the atmosphere naturally that comes down in rain and sticks really strongly to the surface. So we can distinguish this for surface sediments versus subsurface sediments. What I was finding in the one season of data I had that tracer with is that there was a lot of in-channel material moving further down. So when I add a tracer, what it tells me is some of it just stays there, it doesn't move right down. And when I look for the tracers naturally added by the rain, I find that the suspended sediment has a lot of material that looks a lot like other channel sediment. So it doesn't look like a lot of landscape erosion that made it in and moved down. So we think about waterways and where can the sediment go, right? We have these streams that everyone would like to fish in, right? Because they have great fish habitat. Because they don't just look like a chute. They have pools and riffles and rocks. Well, all of that can help hold this material in place, which means it doesn't move right down. So we need to think about how long that might take if we're going to have these associations. Here's another example, right? This looks like great structure in a channel. A fisheries biologist would love this. But it means if we're thinking about making some assessments of anything we're doing on the forest, we should be making them very locally and actually assessing directly what we're doing, as opposed to trying to infer them from going way far downstream. So I know with the technical delay, we're running pretty late. This is the slide where I wanted to just briefly mention, and it can lead to a larger conversation, the acronym question. The RAPS, the One Watershed, One Plan, and HSPF modeling that's been done. So this is the Black Swan, West Swan Creek. It's just south of Hibbing, Minnesota, which is shown there as the red and pink cluster. And then it's mostly a vegetated watershed where we're looking at really instrumenting two stream cross sections to look at discharge and water quality and leaving that instrumentation running and having sensors out there that are continuously running over the course of a few years that we have the funding for this. What the yellow dots are studies that the MPCA lists as taking a water quality sample. So you can see lots of yellow dots all over the page, and this is what's been done historically, and I think it ties into the RAPS program a little bit that the question addressed. But that's not necessarily continuous water quality data. It's people going and taking a sample at a point in time. And so I think RAPS just has a schedule for getting back into that mode. I'm not sure at all about the One Watershed, One Plan. That's a program that I'm not familiar with from the PCA. But I know the goal of a lot of this is to try and get spot data that covers a big spatial area that they can feed into a hydrologic model. And if HSPF is the model that they're using, HSPF in the past, as I'm familiar with it, is not very great at looking at any in-channel transport time that doesn't just move right along with the water. It's very good at sort of water transport time, but not when any water quality measurement that you're looking for might have a bit of a different transport time, especially if it gets beyond years, decades, etc. Let's keeping that kind of a brief. So we just talked about direct versus indirect sediment effects. BMPs work at what they're designed to do, and they have that direct connection for what's going on at the edge of your operation area. Some of these larger correlation studies where you're trying to get at a direct effect can't necessarily get at what's the direct part and what's the indirect part, because they're just looking at a landscape change versus what's going on in the stream. What I really want to encourage people to do is think more broadly about what comprises that solid material in the waterway, how long it's been there, and keeping in mind that some of this could be the legacy of land use past or storms past. And that altering flow can also alter sediment, so that indirect pathway can be a player as we're starting to line up water quality data on these big programs with what's going on our landscapes. So the big punchline, things to keep in mind when you're trying to evaluate the outcomes, all the outcomes of your activities. BMPs work when applied to keep material out of waterways. If you're going to evaluate the effectiveness of your BMP, it's really best to do it right by where you're affecting that, right by where you're implementing it, or in the stream right next to where you're applying it, right downstream of where you're applying it. Because if you're going to keep going downstream, things can take longer and longer, and you can have more confounding effects that might influence your effectiveness assessment. So that's sort of the bottom line. And this is one of the weirs at Marcel that we can nicely look at while I get to the rest of the questions. And I'm happy to have discussions that go further as well, or people can email me, because I know there's a lot going on.
Yeah. Well, Diana, I want to thank you for an excellent presentation. We do have several more questions here, but I really appreciate your rolling with things at the beginning and going with it. So I'm going to assume that the RAPS and 1W, 1P questions are done. I think, have been adequately addressed. If someone wants to follow up on that further, feel free to use the chat pod, but I'm guessing some of that may be more technical than most of our audience is interested in, so we can follow up by email as well. Next question, is there research showing the effects of natural disturbance on evapotranspiration and water quality?
Some that's ongoing that I'm familiar with. So where we're thinking more about the research of natural disturbance on ET, there's a couple of charismatic mega disturbances that come to mind. There tends to be some of these studies following major hurricane and blowdown events. And so those happen, around the world, and certainly within all research regions of the U.S. Forest Service. So hurricane and blowdown events, and then whether or not, any blowdown would affect the evapotranspiration. Whether the blowdown is snap or creates tip-up mounds, that's going to be kind of a different potential to mobilize sediment, for example, and lead to sediment. Other disturbances that could affect ET, a lot of the pathogen kill-off. So Marcelo, where you've recently moved from, a lot of the various beetle infestations and other pathogens that are affecting areas in the Rocky Mountains, that's changing transpiration. And those are studies that are going on. I mentioned the Sierras in California earlier, and that's an area where they're actually thinking about what happens with drought, and can they do more active forest management in terms of thinning, specifically to reduce the ET component. And so that's an area of studies. I know that there have been some studies underway, but I haven't really seen a lot of anything finalized yet regarding all of the 2012 flooding that took place in the Duluth area. So I know that caused a lot of sediment movement and sediment plumes. I don't know if there was any vegetation damage.
Great. Okay, thanks, Diana. Just very briefly, it now is 1 o'clock. We are going to continue with some questions, if that's okay with you. I don't know if, Diana, you need to move on to another meeting. A few minutes, did you say?
Yeah, I can do 15 more minutes.
Okay, I don't think we'll go quite that long. Since you just mentioned thinnings and effects on evapotranspiration, this one might be tough to answer, but how does evapotranspiration change as aspen ages in general? Do you have any data on that?
I'm looking at Marcelo because I don't have data on this. Marcel would be one place to look, but I don't know if they've looked at direct measurements of ET there, other than using this kind of water balance approach. So when I briefly introduced the water balance, ET is the most difficult to measure, right? Especially separating it out into transpiration, soil evaporation, evaporation from any open water body. So a lot of times what hydrologists will do is measure everything else and get the ET by the balance. And so I'm pretty sure we could dig up some data from Marcel where that's possible, but I don't know of any numbers off the top of my head.
Okay. Question to clarify some data that you presented earlier, I think in the paired watershed study from Idaho.
Sorry, I'm trying to go fast.
So the question is, so the water moves faster than the sediment it's carrying, and sediment may or may not fall out depending on, may or may not fall out on the way, depending on things like flow rate, obstructions, channel depth, etc.
Yeah. And if we think about getting more floods too, if you think about a flood that goes out of the channel, so you have the river coming out of its banks. The water that's flowing within the main part of the channel versus the water that's flowing over the riparian zone or over the floodplain is going to have very different properties associated with it. That's how we get floodplains building up. It's because sediment settles out of those overbank floods. What I was working with in Idaho, we didn't have an overbank flood at that time. But yes, depending on if the water exchanges between the stream channel and the stream bed, you can lose sediment that way. If you go into those pools where the fish like to hang out, the water is going to slow down and often the sediment will settle out to the bottom of those pools. Are some examples.
Okay, another question. Have tree or cedar revetments been practiced in north central or northeastern Minnesota for smaller streams that can support increased flow velocity while acting as a sediment catchment in the stream channel?
I don't know.
Yeah, not sure. Adam, if you'd like to add any more information about that, or maybe we can try to follow up, but we're not sure on that one. And I think that gets us pretty close to the end. There are a couple of questions that we may want to come back to after the fact, but I think I'm going back through all of these, and I think we've got, I guess there's one more here at the end that you partially addressed, Diana, in response to the natural disturbance question.
Sure.
Do you know of any studies focused on sedimentation following forest fire, maybe the Ham Lake or Pagami Creek fires in northern Minnesota?
I don't know of any following those.
Okay. All right, I'm going to draw us to a close. Again, I want to thank Diana. It's not easy. It's a little bit weird to give a webinar anyway, and when the technology doesn't work right off the bat, that can be difficult too. But I want to thank Diana for a terrific presentation and for doing a great job dealing with all of the challenges that came up today. To follow up, folks, if you plan on requesting continuing education credits today, if you have not seen the link in the chat pod, please go ahead and take a look at that link. If you're not seeing it for any reason, you can email Julie or me and we can provide it to you. You do need to sign up for those continuing education credits. Usually I think that form closes about a half hour after the presentation, so you do need to do that right away. We will send a follow-up email with a link to the recording of today's presentation, and I would invite folks to, if you do have additional questions that we didn't get to, please email, well, you can do one of two things. You can either put them in the chat pod now. We will be recording that, saving that chat pod and making sure we've addressed the questions. Or you could email them to Julie or me. and we'll pass them along as appropriate. Any questions in this room before I completely forget about all of you? I don't see any. All right, thanks everyone for coming.
Thanks.
We'll see you next time.
Thank you.